welcome to our SPICE course. My name is Claire, and today we're going over data structures. So Python, like a lot of other programming languages, have their own built-in data structures. And this is basically a way for you to organize and manipulate your data. Most data is read in and manipulated as some kind of data structure, so they are really important to understand when you want to play around with your data. So in this lesson, we are gonna go over tuples and dictionaries. I have like this kind of cute list on different Python data structures and how to initiate them and some examples. We previously talked about lists, so we'll move on to tuples. Tuples are very similar to lists, except that they cannot be changed, and they have some different methods. So here we have an example of instantiating lists. I mean, not lists, tuples. Tuples are collections of different objects, just like lists are. And you can slice into them the same way you can do with lists, just by like giving the index or giving them a range to go through. Remember that for stuff like range, the first index is included, but the second one is excluded. So this is going from the second index to the third index. Tuples can be concatenated together. So here we're combining two tuples, and so we have our new tuple with a collection of even more objects. Tuples can also be compared. So here we're seeing if there is a character in one tuple and is it in the other. And so we can see that there is an overlap where both of these tuples have B and C. Here we have my favorite data structure, which are dictionaries. And what's the foundational idea behind dictionaries is that they function by a key-value pair. That's why they're called dictionaries. It's just like if you wanted to look up the definition of something in a dictionary, you first look up the word. And so in that case, the key would be the word that you're searching for, and then the value would be whatever the definition is. And so that's like the fundamental idea behind dictionaries. Here we have a dictionary called capitals. They're instantiated with this curly brace. You have the key, which is the United Kingdom, and then the value, which is London. And so we define these key value pairs by you have the string, and then you have these semicolons, and then the other string. We can update our dictionaries by using this update method. So if you wanted to change the value of a certain key, in this case we're changing the value of United Kingdom to England instead of London. And so we just use the update function and it will automatically update our key. Here we show how you can actually get the values returned by giving a particular key. So in this case, we have a dictionary with keys of names, age, and class, and we can return the value by giving it the designated key. So in this case, we're giving it the name Zara. Well, actually, we're giving it the key name, and then we're getting the value of that name, which is Zara. Additionally, here we're giving the key age, and we're getting the return value, which is 7. So you can see how dictionaries are really good for data storage, especially if you have data that can be separated into different types. Like in this case with this, here we're documenting probably like an elementary school list, and we can separate the data between name, age, and class. And so then we can easily get our data and be able to do calculations across these different key values. So maybe I want to like get an average age of the second grade, or how many grades are in the school, that kind of idea. If we do not have a key in the dictionary, it will return an error when we run it. See, there is no key called Alice. Additionally, even if we had a value that is Alice instead of Zara, this will still throw a error because we can only search dictionaries by keys. We cannot search them by values. And so we have Alice in the dictionary as a value, but not as a key. And so that's why we're still getting this error. We can update our dictionaries by, again, having the key and then assigning it a new value. We can also add a new entry by having a new key and value pair. And we can see that the dictionary now has a key that is called school, and that value is this DPS school. And we have the age that we updated to 8. So it looks like Zara grew up a year. And so dictionaries are very good for keeping track of these like labeled data. You can also print all of the keys, as well as like all of the key value pairs and etc. For more information, you can look up the different methods in the dictionary documentation. So now that you know a bit about dictionaries, try doing the dictionary problems on Rosalind, as well as try doing some more additional string algorithm problems like before. And maybe there are even more problems that you are able to solve since we covered a bit more information now.